Good morning. Thanks for your time today. There's broad agreement in the Ethereum stack across all of the layers on the mission of onboarding the next billion people. That's easy to say, not so easy to do. I want to talk about what it is that we as a technology stack and community need to do to make that real, to get to onboarding the next billion users. And I want to start with the very simple notion that people talk about a lot, and that is alignment. But when I talk about alignment, I'm not talking about aligning with each other, which of course is something we should be doing. I'm talking about aligning with users. If we want to get those billion users on board, we have to align with them. And if we all align with them, then we'll be aligned with each other, and we'll be aligned with each other in the right way. So I think aligning with users and thinking as designers about what is it that our users need from us and from our stack, and how can we work together to make that happen, is one of the keys to success and to getting to that next billion. But beyond that, I think there are 6 big moves that have been made or are being made in the Ethereum stack to get us to a technology environment that is able to meet the needs of those billion users and to operate at that scale. And I want to spend a little bit of time going through what I think those 6 big moves are and why it is that they're important. So the first big move that is already well underway is the idea of building in layers. Now, there's a lot of debate across crypto Twitter about whether layering is a good idea. I think layering is not only a good idea, it's really the only idea if you want to build a sustainable protocol. And in doing that, I think we can learn from the most successful protocol stack ever invented, and that is the internet and TCP/IP. Layering is fundamental to the operation of the internet. And it's beneficial in at least 2 ways. One way is that by building this way, you have a natural kind of modularity. Each layer can focus on doing what it needs to do, meeting its own mission. You don't have to replicate functionality across layers. Each layer does its job and then provides that as a service to the layers above, so the layers above don't need to replicate that work. That's been incredibly successful. The other thing that has been a huge benefit of layering for the internet, and also for the Ethereum stack, is that you can have a diversity of different approaches and applications across this stack. If you notice the stack over here on the left, there's some degree of branching there. And that's because there's a diversity of technologies meeting a diversity of needs because of layering. And that's critical for Ethereum as well. Again, when people talk about fragmentation, I would flip this around and say what some people call fragmentation, I call choice. And choice is a good thing. Diversity, trying different things, seeing what works, and deploying for each user community or application the support that they need, instead of trying to build one monolithic layer that is all things to all people. So Vitalik saw this early on. Of course, famously back in 2020, talked about the roll-up-centric roadmap. And this is the application of that layering principle to Ethereum, and I think it's been fantastically successful. So just to give you an idea, today, roughly these days, what we see is the layer 2 plus layer 3 ecosystem has multiplied the capacity of Ethereum by a tremendous factor. It's about 30x the TPS of layer 1 these days, about 80x the gas used, about 40x call data, and currently around 100 L2 and L3 chains. So the idea that L2 and L3 is taking traffic from Ethereum is not really right. What's really happening is that it's adding to the Ethereum stack. So just to illustrate that, let me show you a graph or a graphic showing you where the gas consumption in the Ethereum stack is happening these days. This is drawn to scale. L1 is about 1.5% of the total gas in the stack. L2 and L3 split the remainder about equally. There is a little bit of L4, actually, but it's not shown here. So this is one of the ways in which layering has been so successful for Ethereum, increasing the capacity. And as we bring on board more chains, and as we do these additional big moves, this advantage of Ethereum will only get larger. Right, and so what are the advantages or the roles of the different layers? Well, at the bottom layer, you have Ethereum, which provides economically secured consensus, something that is incredibly valuable Also incredibly expensive, paying out billions of dollars of rewards to proposers every year. We don't need to or want to replicate that in the layer 2. Layer 2 can build on that and focus on low cost, fast response time and scale, as well as innovative execution models. That's all possible at L2. We can do that without needing to replicate the incredibly expensive and foundational economically secured consensus. Layer 3 offers the lowest cost, and as well as many of the other advantages of layer 2. Big new move number 2 is to, when you have all of these components, different chains meeting different needs, is to connect everything. Get these pieces to be able to talk to each other effectively so that they can work together as a single stack in a single community. That's L2 interop. There's a ton of discussion about this, but I think not as much clarity as at least I would hope to see in the conversation. So connecting everything is important, but it's critically important how you connect things. That's been the case with the internet. It's not enough just to wire things together. You need to think about user experience. You need to think about all kinds of other factors in order to make this practical. So how is just as important as whether. And how is actually the hard part, because we can all agree that we want to connect everything. So I think we can learn a lot, again, from the internet when we think about how interoperation can and should work in the Ethereum stack. If you look at how the internet does interoperation, it has a bunch of different features. It's fast. It's standards-based, importantly. Those are two things, obviously, we want to emulate, and there's valuable work going on standards. It's asynchronous, meaning that the components don't stop and wait for each other. You find ways to go on to operate in a less tightly coupled way. You don't stop and wait because the other one might take a long time, or it might not respond at all. It's also fault tolerant. You don't assume in internet interoperation that the other component will necessarily even be there, will be up or available. You don't assume everything is going to just work. You build a system that can tolerate the failures and stoppages of the components. And it's security conscious. You don't assume that the other component will necessarily be secure. Because if everything assumes that everything else is secure, then you've created a giant vulnerability where one failure in one place can take everything down. So we can learn a lot from all of these things. I think we want to build interop that's fast and standards-based. But I think we can learn from the internet, for example, that asynchronous is valuable. Notice that in the internet, even two machines inside the same data center, literally inches or centimeters from each other, operated by the same administrative body, operate asynchronously, fault tolerantly, and in a security conscious way. Even then, they don't trust each other to operate that way, and that's why internet technology is so robust. We would do well to emulate that. Now, there's basically two ways of thinking about interop between L2 and L3 chains. One way is the sort of cluster-based, the idea that we're going to establish a common framework, we're going to have common governance, you give up governance of your chain, and we're going to require sort of lockstep upgrades and common shared infrastructure. Now, you can do that. There are some advantages from doing that, but you give up a lot, and I think in the end, it doesn't provide enough benefit. I think we're better off mostly doing what is done on the internet outside of individual organizations, which is loosely coupled interop. The idea that you take as the norm that the different components are working together, even though they're separately operated and they don't fully trust each other to be available or secure. Big move number 3 is developers. Thank you, Steve Ballmer. Focusing on giving developers what they need to build really state-of-the-art applications. And I would argue that's a bunch of things. It means supporting familiar, standard, battle-tested languages and tools. It means supporting fast execution. And it means building an environment where everything that you do on-chain is fully composable and fits together, where you're not building silos of pieces that don't work together. The thing that we're doing in the Ethereum, in the Arbitrum stack to do this is Stylus and the multi-VM. This is the idea of running together on the same chain, multiple VMs. You can run EVM code, you can run WASM code compiled from Rust, C++, or other languages. It all runs together in the same execution environment, fully composable. That's where we want to go. Alt VM is nice. Multi-VM is the future. Big move number 4 is to make it fast, and make it fast for real. That means not just having a big TPS number you can quote that you measured in an unrealistic environment. It means building something that will operate fast actually for users on a real chain with a large state, with a large and diverse set of applications. So what can we do there? There's a whole bunch of things we can do to work toward that goal. Building better benchmarks, standardized and realistic ways of measuring performance so that we can compare across different implementations. Faster execution, faster VM, faster database, and so on. Parallelism, the ability to discover and exploit parallelism when it's available without making programmers worry about it. Resource pricing, better resource pricing means that we can better align incentives so that developers are using the resources of nodes and of the chain more completely and efficiently. And then finally, the use of sharding on individual chains in cases where you really need to push performance. So all of these things are important and going on, I know, across different teams in the space. Big move number 5 is technical decentralization. That means taking the technical aspects of the system and arranging so that they're decentralized, truly decentralized, meaning that power is not centralized. True decentralization means more than just an on-paper right to participate. It means that power really is dispersed. So let me talk a little bit about what we're doing on the Arbitrum team community toward that goal. There's a big upgrade coming up soon that is proposed before the DAO, which we call BOLD, which is an efficient and fully decentralized proving protocol. It is the first and only secure fraud-proof protocol that's resilient against 7 days of L1 censorship, which is the gold standard, has fixed completion time no matter how many adversarial actors there are or what they're doing, allows honest parties to pool their stakes so that you don't have to come up with the full stake yourself. You can pool your stake with other honest parties in a completely trustless way, and doesn't rely on a Security Council veto as a core part of the chain's security story. Given this, we'll have a situation where any one user can enforce safety and progress of any Arbitrum chain. The other thing that we're doing toward decentralization is time boost. Time boost is a mechanism for allowing a chain to capture a large portion of the MEV value that it generates. And I'll skip over, because of time, the details of how time boost works. But one of the best things about time boost, in my mind, is that it's fully compatible with decentralizing the sequencer. And we have an ongoing joint project with Espresso Systems, Offchain Labs and Espresso Systems, to develop a decentralized sequencer that preserves all of the good properties that Arbitrum sequencing currently has, including very fast block times down to 100 milliseconds, as well as protection from front running and so on, while being decentralized and being compatible with time boost. The work on this is underway as I speak. And then finally, the last big move is decentralizing control. What does that mean? What that means is getting beyond what some people call a decentralization theater. Decentralization theater is where you have a lot of pretty web pages and a lot of pretty tweets about how you are a robust community, but at the end of the day, it's really all controlled by a multi-sig of insiders. The DAO gets to vote, but the vote is just a polite request to some multi-sig, for example. It's incredibly important that we not only talk about decentralizing power and control, but that we actually give power and control to users. So I'm really proud of something that was done in the Arbitrum stack to do this. On Arbitrum 1, when the DAO votes, those votes are self-activating, self-executing on-chain. There is no multi-sig that has to do the thing. When the DAO voting contract says the DAO has voted to do something, that thing happens immediately on-chain via smart contract. That is real power for the DAO. There is no multi-sig that has a veto. So decentralized control, true decentralized control, is key to actually getting there. And there's a lot of progress there as well. Okay, so 6 big moves. I'm not going to repeat them for you. Together, doing those together, we can get to that point. We can be aligned with our users, and we can have a technology stack that is robust, diverse, and can support those billion users. That's the goal I think we should be working for, and I'm grateful to everyone in the community who's working toward that goal. So what is the future of L2? Well, the future of L2 is the future of Ethereum. We're in this together. And L2 and Ethereum will succeed together, each one succeeding because we contribute to the success of the overall Ethereum stack. And most importantly, if you're a user, if you're a builder, the important thing to remember is the spirit of your chain, your rules. That is, we're building this for our users to be aligned with them and to put them in control of the way that they use and interact with technology. That's the goal, and again, thank you to everyone in the community who's working together toward that goal. Thanks a lot.